Welcome to the math record. Today I'll be covering the second derivative test. In the previous video, we introduced the concept of concavity. In this video, I want to use the idea of concavity to find max and mins. So you might have noticed this in the previous video, but it kind of seems like concavity and max and mins are kind of intertwined. And they are, because if we have a concave up, we have a minimum. If we have a concave down, we have a maximum. So we just combine both ideas together. What makes a minimum? Well, in our video for max and mins, we said that the first derivative had to equal 0 or it's undefined. What about concave up? Well, concave up, we said that second derivative has to just be positive. Now what about for max and concave down? For max, similar to mins, the first derivative has to equal 0 or undefined. Or and then for concave down, the second derivative had to be negative. So combining them both together, we get our second derivative test. So let's delete this. And this is referred to as the second derivative test. So let's try an example. So let's say f of x is equal to x to the power 3 minus 3x squared minus 45x. First, we got to get the max and min, so we got to make sure it's equal to 0 or undefined. So first derivative. So that's 3x squared minus 6x minus 45. So polynomials obviously cannot be undefined, right? So can't be undefined, so we just set it equal to 0. So set 3x squared minus 6x minus 45 equal to 0. Let's factor this. So that's 3x squared. 6 divided by 3 is 2. 45 divided by 3 is 15. So factoring our quadratic, we have x minus 5 and x plus 3. So to make 0, that means x is equal to 5 or x is equal to negative 3. Okay, so we get our first thing out of the way. So to check if it's a min, we need to know if it's the second derivative is positive, or if it's a max, the second derivative is negative. So using that, we do the second derivative of this. So that would be derivative of 3x squared is 6x. Derivative of negative 6 is negative 6. And derivative of negative 45 is 0. Now we plug in 5 in here. So the second derivative at 5, that's 30 minus 6 is 24, I mean. And the second derivative at negative 3. So at negative 3, we have negative 18 and negative 24. So this one is positive and this one's negative. So at x equals 5 and x equals negative 3. So that means at x equals 5 which we have our second derivative positive, that means it's a min. And at x equals negative 3, which is when we get our first derivative 0 also, we get a concave down, which is negative, and this is negative. So this is obviously going to be a max. And that's basically it. All we had to do for the second derivative test, we're given our function, we take the derivative, set that derivative equal to 0, solve for the zeros, and then get our second derivative, plug those zeros in, and check if it's positive or negative. If it's positive, it's a min, and if it's negative, it's a max. So all we do is combine the idea of the first derivative test and our idea of concavity. Well, in the next video, I'll be covering some theorems in calculus. Thanks for watching.